service again with yet another math video. And what in the world is this thing? Oh my goodness. So what are you doing? Is that a bonnet on your head? Oh my goodness. No, dude, it does not go really well with your... It does not go good with your... What's up with the red dots anyway? Oh, really? Well, maybe you shouldn't use so much dye in your hair the next time. Oh my goodness. You know what? This guy, he's too funny. Alright, hey, we're here for this wonderful math video. This is the third video in a series of 3 covering Chapter 5. Let's go ahead and shrink this guy a little bit so I can do some work and try to keep a serious face, of course. Here we go. Tabitha bought peppers that cost 79 cents per pound. She paid $3.95 for the peppers. How many pounds of peppers did she buy? I thought this was going to be like a tongue twister. I think the first thing that we need to do is to understand what the problem is asking. If Tabitha bought peppers at a certain cost per pound, and we have the amount of money that she spent in total, as I said, she paid $3.95 for those peppers, and we have a certain rate that those peppers were sold at 79 cents per pound. I'm hoping that you're starting to see what the problem is asking us to do is to divide, to take our dividend of $3.95 and divide that by the divisor, that rate of how much she had to pay per pound for those peppers, which was 79 cents. So I'm going to go ahead and put my $3.95 here. And then, of course, I have point, and I'm going to leave the 0 out, but I have 0.79 here as my divisor. You can see immediately I have a decimal in the divisor, and that's a problem. I could multiply it by 100 actually, okay, to remove that decimal, and I'm going to do the same over here. And then up here, up, and away. Yeah, the decimal is going to move up here now. We moved it. Now something you may notice right away, and this would be another way that you could solve this problem, rather than move the decimal out here, so what you could do now simply, since we multiplied by 100, you could take 395 and divide it by 79. Rather than trying to multiply a lot of different numbers, trying to figure out how many times I can put 79, how many groups of 79 into 395, something that I like to do is I like to go ahead and think about estimating the numbers like we have been. Like this number here, we have 79, that's practically 80. Just think of this number here as being 8. Okay? And then over here we have 39. And 39 is practically 40. How many times would 8 go into 40? See how I'm doing that? So let's not look at the 9 or the 5. So how many times will 8 go into 40? Well, it goes into exactly 5 times. Let's see if 5 will work for this problem. So if we had 79 now, multiplied by 5, wasn't that cool? Now this is really all we're doing. What makes this work is, number one, is that remember that we have a 79 here and it's about 80, but even if we just used the 7, that would have been fine. The key is that what we're doing is we're taking our dividend and divisor and we're like almost dividing it by a power of 10. Rather than trying to look at this huge number, trying to get in this larger number, let's go ahead and just almost like divide by a power of 10. So we just look at the 7 into those first 2 digits, 39. And just makes it easier. So we end up with 5 and we get 395. Not much to check our work because that's exactly what we did here already. So that's it, my friends. Yes, we showed our work, we showed our understanding. Let's go on. Hank has a large bag of trail mix that weighs 7.8 pounds. He uses the mix in the large bag to make bags, each containing 6 pounds of mix. How many bags containing 6 pounds can be made? All right. Think this is my dividend, my 7.8 pounds, because that's how much we have. We're using that mix there when they have that big large quantity in that large bag to make bags that are less, 0.6. Can you see where that dividend stands out? That's right, 7.8 pounds. That becomes our dividend. That's the number that we're trying to divide. And then we have our 0.6 pounds of mix. That's going to be the quantity that we're going to use to determine how many bags we're going to need. So let's go ahead and set this up. Now, like before, we have 7.8, okay, and we have 0.6. What we could do is multiply this by 10, and that will make it 78. We're going to go ahead and multiply the 6/10 by 10, and we're going to get 6. Really, what we're doing is we're doing something equal to both the dividend and divisor and not changing the value. So if I were to take 78 then and just divide by 6, you can see this 6 is going to go to 7 one time. Okay, I need to subtract. I bring down my 8, and then nicely this works out to 3, giving me 18 with none left over. So I end up with 13 bags. That worked out perfectly. Now, is it going to work had we not taken the decimals out? Of course, because all we're doing here is the same thing. We're saying I'm going to multiply by 10, multiply by 10. And you see, it's the same thing. That works. But you have to be careful here. You have to always remember that you can't decide to multiply one of these numbers by a different quantity or you're going to change the value. Okay. Oh yeah. Yeah. Okay, let's go down. Now we have Shireen walked a total of 9.52 miles in a walkathon. Wow, that's quite a few miles. If her average speed was 2.8 miles per hour, how long did it take Shireen to complete the walk? Now, we have been focusing on division in this chapter, so it's more likely than not, right, that our problems are going to be dealing with division. However, we always want to try to make sure that we understand the problem and then what we're going to need to do. Yeah, we do have a total of 9.52 miles. There's your dividend, okay? And if your average speed is 2.8 miles per hour, well, we could take that distance and divide it by that rate, okay? And that's going to give us the time. There's actually a formula for that. So if we look at this problem and when we look at that dividend, we can see that the dividend goes to the hundredths place, whereas the divisor here goes to the tenths place. I'm going to come over here and I'm just going to do the standard long division. Now remember, the rule is that we can't leave the divisor with a decimal, so we're going to multiply by 10 here, and then we're going to multiply by 10 here, and then here, up and away. Yeah, okay, whatever, Mr. Tor. So now I have my decimal point here. Now I have 28. Now what I could do is 28, I could probably figure this out in my head pretty easily, right? 28 is about 30, so if we put 30, 60, 90, we can figure that it'll go in there 3 times. And we'll come over here and do our 28 times 3. Looks like 84 to me. Now I'm going to put my 84 here. I subtract, I get 11. Now remember, that remainder must always be smaller than my divisor, or I might not have taken out as much as I should have. But I have 11 and that works. Now I'm going to bring down my 2. Now that was 3. Now we're assuming these problems are going to be nice. 28, 30. Let's say these problems are going to be nice and it's going to end here. So I'm going to go ahead and take my 28 times 4. It looks like 112. So 4 was the lucky digit there. And we end with none left over. So we get 3.4. And we were dealing with hours because the unit of measure was miles per hour. So that is going to be 3.4. Now we could double check. This is one I probably would want to double check. 3.4 times 2.8. 32, carry the 3, there's 24, looks like 27, placeholder, then we have 8, and then we have 6. We're going to add 2, 15, carry the one that's 8, that's 952, but of course I have 2 decimal places here, and then I get back, I get to 952. Now the only way that we could have done it like we did in the previous problem by multiplying by 100, both the dividend and the divisor, to avoid the decimal point in the in the divisor and the dividend, is just to multiply by 10 like what we did here. So if you recognize that as being the divisor, you could have just multiplied by 10, said, okay, I have 28 and I have 95.2, much like what we solved over here. Okay, man, yeah, I'm telling you, this is just fun, more fun, and I don't know, like pigs rolling in mud? I don't know. Anyway. And for number 17a through 17c, it says choose yes or no to indicate whether a 0 must be written in the dividend to find the quotient. And I actually need to solve these, I suppose. What do we have here? 1.4. We're going to divide that by 0.05. So if you look at this here, I suppose since the divisor has 2 decimal places, we'd have to multiply by 100. And here we'd have to do 1, 2. So the question was, does a 0 need to be added in the dividend? It does. All right, we have our little loop-de-loop, loop-de-loop. And that space there means that we do. So the answer is going to be C. Yes, you do need to do that. What do we have next here? It looks like we have 2.52 divided by 0.6. Okay, starting to see the pattern now? No, we don't need to. So we actually just look at the dividend. See how many decimal places. Here it's going to move 1 time. So that decimal place is going to be 1 time over here. So we will not need any zeros here either. Yes, no, no. That's the pattern. Okay. Lisandra made 22.8 quarts of split pea soup for her restaurant. She wants to put the same amount of soup into each of 15 containers. How much soup should Lisandra put in each container? Hear that sound? I got that total amount. I'm splitting up in equal groups. Kind of should let you know that 22.8 quarts. Yes. Dividend. Then my 15, that's my divisor. Yeah. So let's go ahead and do that. We're going to take our 22.8. We're going to divide that by 15. Okay. Decimal point. Up, up, and away. Okay. There we go. And then 15 is going to go into 22 1 time, because if you double that, that's 30. Way too much. We're going to need to regroup, and that's going to be 7 remaining. And 15 is going into 78. Is that going to go in there nicely? I can't think. 15 times 5 is 75. I don't think it will. Ooh, they're going to make us work on this one, huh? 75. That's right, with 3 left over. Guess what? I need to add a 0. I do. Because we're not going to leave it like that. The division that we've been doing, we don't want a remainder. And so now if I bring that 0 all the way down, just like I did the 8 here, now I have a nice 15 times 2 equals 30. Whew, voila. Yeah. So 1.52 quarts. I double check my work? Sure can. And free of charge. Why not? Okay, 15. I'm going to multiply. I have 10. Carry the 1. 25. That's 26. Carry the 2. I have 5, 6, 7. And then I have placeholder, and then I have 2. 1, 2. 22.8. Yes. And 22.80, of course, is the same thing as 22.8. Just called an equivalent decimal. There we go. Oh my goodness. We're already through the first page. You know, this is going very fast. Let's keep going. Sorry, I just, you know. You really got to lose the bonnet. You know, I don't think you look half as bad. I know you got that weird disease thing with the red dots, but, you know, hopefully that'll clear up. I don't know. Percy buys tomatoes that cost 58 cents per pound. He pays $2.03 for the tomatoes. That's pretty cheap tomatoes, I think. They're a little bit more expensive than that now. Anyway, maybe they're little ones. It says Percy estimates he bought 4 pounds of tomatoes. Is Percy's estimate reasonable? Explain. Well, we've done this before. This is what we're looking at, the price per pound, and this is how much the total paying. Now, he says that he bought about 4 pounds. Well, if we rounded the 58 down to 50 cents, that would be so much easier to deal with. And if that's just $2, 50, 50, 50, 50, yeah, that's pretty easy, don't you think? It's just going to be about 4 pounds. You just have to kind of remember when you look at these numbers, like 58 cents, you know, it's close to 5 tenths. So if you're looking at that tenth slot, and the same with the $2.03, it's really close to 20 tenths. So if we kind of think of 5 tenths and 20 tenths, well, 20 tenths, right, divided by 5 tenths is going to be 4. So 4 pounds of tomatoes, pretty reasonable. So how many pounds of tomatoes did Percy actually buy? Show your work. Well, we had, let's see here, this is where we can multiply by 100 here, because you can see that's going to clear the decimal. So if we were to multiply that by 100, we're going to get 58, and here we're going to get 203. So that's definitely something that we could do. If you wanted to show that, times 100 is going to remove that decimal, make it really easy to deal with. Whereas the other one, the $2.03 times 100, that might make it a little bit easier to deal with, so we don't have to do it over here. I'm kind of showing you both ways. Okay, so 58 is not going to go into 20, it's going to go into 203, but how many times? Well, we already kind of determined that it's about 4, but since this divisor is larger than 50, I'm going to have to say 3. We're going to have to back off 1. Okay, because when we were figuring the estimate, we were bringing this all the way down to 50. Looks like 174. Okay, a lot of regrouping I need to do here. So we end up with 29 left over. Well, this is a problem because we can't just stop there. This remainder is not going to help us. We need to know price that he paid. So that means I'm just going to, at the end of my digit here, I'm going to put a decimal. And of course, up, up, and away. That's right. We're going to have to move this up. Now I can continue on. It's the end of that whole number part. Now I continue on. I can put as many zeros in here as I want. Okay, it doesn't matter. Might not need that many, but we'll see. Now if I bring 1 0 down, I have 290. Kind of difficult to figure out how many times 58 is going to go to 290. Maybe we can look at that instead and say how many times will 5 go into about 29? Maybe 5 times or 6 times. Now it's interesting, if we multiply that by 5 underneath here, that's going to give us a 0 in the very last place. So that's what I'm going to do. So 58 times 5, it worked out nice. It doesn't always. Math doesn't always work out great the first time, but there you go. We have none left over. That was our 5. So we're done. We didn't need all those zeros, but that's okay. So we end up with 3.5 pounds. So that was the actual amount. The actually. All right, because we always have that. We have that estimated. So 3.5 pounds of tomatoes. All right, who drove the fastest? Select the correct answer. Let's go ahead and do A. So we're going to take 363 miles and we're going to divide that by 6. That's going to go there 6 times. At least they made up nice, easy problems, right? Now we have our 3. Oh, 6 can't go into a 3, so that's going to be 0. We need to add in our decimal, up, up, and away, and then we put in our zeros. Let me extend my line. Now bring my 0 down. You can see. So this one here is going to be 60.5 miles per hour. We're taking our miles divided by how long it took them. 7 goes into 43, 6 times, which is 42. I subtract, I get 1, bring down my 5. 7 will go into 15 twice. And then you can see that's going to be 14 with remainder 1. Let me go ahead and keep going. So I have to put in my decimal. Up, up, and away. Okay, and it's up there. And then I'm putting a 0, maybe a couple. We may only need 1. Now I'm going to go ahead and bring down my 0. And you can see the 7 goes into 10 just 1 time. I'm subtracting. I'll bring down another 0. Will that go in there nicely? It won't. It'll go in there 4 times, which is 28. So in this case, was it 435 divided by 7? It was. 42, 1, 5. Okay. I'm checking my work here because I'm surprised they're giving you this challenging problem here. So 14, that was 1. Am I forgetting a digit? No. That ended it there. I brought down my 0. Okay. 3. Okay, good. And that's going to go in there 4. That's leaving me 2. Can bring down another 0. Go in there, what, 2 times, 3 times, 2 times. That's 14, at least 6. It doesn't look like this is going to solve anytime soon. So what I'm going to do with this one here, for the time being, I'm just going to go ahead and I'm going to round it off at the hundredths place. All right, let's see what happens here. Next we have 500 miles in 8 hours. All right, I'm needing some more room here. Maybe we want to move some stuff around. So now if I take 500, 8's going to go into 50, what, 6 times for 48. Subtract, I'm going to get 2 left over. 20, well, it's going to go in there twice. That's going to be 16. That'll leave me with a 4. Now, you know, put a decimal in here because I'm out. Up, up, and away. That's right, it needs to go up, okay, up above. And then I bring down my 0. And of course, this is pretty nice. At least this one ends here in the tens place. So I get 62.5. Okay, this is just a little bit faster than Kevin drove. Finally, the last one. So I did my little shrinky. They're all small. All right, now I have 215. I'm going to divide that by 5. 5 is going to go to 21. Almost said 5, but no, that's 20. See, that leaves me with 1. Bring my 15. So that's going to be 43 miles per hour. So you see, by looking at our numbers here, that C, Shauna, she's the one that drove the fastest. Hector drove the slowest at 43 miles per hour. Hope that wasn't on the freeway. But these are really, really close. Probably the most challenging problem I think so far that I've come across here in this review. And the big key being that we had to add zeros. So once we started dividing those numbers out with the 500, with the 435, then we had to add a 0 to continue on to see what the actual decimal places would show. And that's pretty much it. Woohoo! Let's go to Maritza is buying a multi-pack of 3 pairs of socks for $25.98. It says she will save $6.39 by buying the multi-pack instead of buying 3 individual pairs of the same socks. If each pair of socks costs the same amount, how much money does each pair of socks cost when bought individually? Show your work. Interesting. Okay, so on this problem here, this is a situation where there's a couple things going on. Well, because you bought a multi-pack of 3 pairs of socks, right, for a certain price. And then, but she saved some money. By doing that, she actually saved money. It should have cost her $6.39 more. So since she saved some money, she would have spent more had she not bought the multi-pack. So what we need to do here is we need to add that $6.39 onto the amount that she paid to to find out what it was, what the amount would be had she not saved any money. Kind of keep in mind is that $6.39 is a savings. So if I have my $25.98 and I add on my $6.39, we can find out what she would have paid without the savings. And here we have 17, carry the 1, that's 12, 13. Oop, bring her on down. Okay, 12, 13, carry the 1, 11, there's 12, carry the 1. So we end up with $32.37 is what she would have paid had she not gotten that savings. So now how are we going to figure out what she would have paid for each pair of socks, since we know that they were the same amount? Well, we take our 32, 37, we're going to divide that by 3, right? Because there's 3 pairs of socks. I have a decimal point here, so up, up, and away. Okay, up there. And then 3 is going to go into 32. Oh, 3 goes into 3 one time, right away. And then we end up with nothing left over. We bring our 2 down. 3 can't go into 2. But you have to remember, when that 3 can't go into that remaining amount after you brought down a digit, then you know you got to say I put it up there 0 times. Okay, now I can continue on. Now I have a 3. 3 goes into 23. Looks like about 6 times maybe said. Oh, 7 times. So 7 times is 21. I'm going to subtract and I get 2. I bring down my 7 here. Oh, that's nice. Works out great. Because 9 times 3 is 27. I'm going to go ahead and do that. Write my notes. So does it say show your work? Well, we showed all our work. I think I did plenty of enough explaining here. So each pair of socks would be $10.79. All right. Now, number 22 says Eric spent $22, including sales tax, on 2 jerseys and 3 pairs of socks. It says the jerseys cost $6.75 each, and the total sales tax was $1.03. Fill in the table with the correct prices. Well, what do we know here? We have cost of each jersey. Do we have that? We do. It is $6.75. We have the sales tax. That's $1.03. And then does it give us the cost of each pair of socks? It doesn't. So, I see. It wasn't that easy, right? So we have to do a little bit of work here. Well, if we know that the 2 jerseys then, that each jersey is $6.75 and we have 2 of them, we could find out what would $6.75 be double. So we can find out how much the jerseys were together. So the 2 jerseys then together would be $13.50. Now I also have my my sales tax that was added on there. So I'm going to go ahead and put my $13.50. I'm going to add on that sales tax. So we end up with $14.53. So what we're basically doing here is like an equation. We're saying that, and I'm going to write it right across here, times 3. But you see, we have all this. We have the sales tax. We added that. We have our jerseys. That's $14.53. So what we can do now is we can say, well, wouldn't $22 then subtract, if we subtract the $14.53, wouldn't that give us the cost of 3 pairs of socks? It would. Let's subtract $14.53. So we end up with $7.47. But remember that $7.47 is for 3 pairs of socks. Here's the cost of each pair. Oh, so I'm still not done. And I'm trying to figure out, I need some room here. I guess I'll just come up here. So that means now I'm going to have to take my $7.47. I'm going to have to divide by 3, up, and away, just to find out what 1 pair costs. So 3 goes into 7. It looks like it's going to go in there twice. That's going to be 6. So we subtract 1. Subtract the 1. We get left with 1. Now I bring down my 4. That's going to go in there what? 4 times. That's 12. That's going to be 2 left over. Oh, yippee. All right, it's going to work out nice. And that's 9. So that means each pair of socks is going to be $2.49. Wow, that's kind of a doozy of a problem, wasn't it? I think I have it writing all over my paper. This was mega multi-step. All right, you know what, my friends? I can't believe another video completed. Woohoo! Yeah, it always feels good, you know, when you do your work. You do your work, you get it done, and you look at your page and you're like, yes, I can do it. Now, of course, as I always say at the end of every video, hasta la vista. Nah, just kidding. Live long and prosper.